Okay. Good day, everyone. Okay. So for our subject, dynamics of rigid bodies. Okay. We will have another topic. Okay. So this topic is about absolute dependent motion analysis of two particles. Okay. So this will be our first example figure. Okay. When we say motion analysis, okay, from the root word motion analysis of two particles, we are talking about of two different particles moving, okay, in which, okay, for example, if let us say one particle is named particle A and the other particle is named particle B, okay, so if this B moves into that direction, for example, this A will also be in motion. Okay, so maybe we'll have another uh, figurative example, okay, in terms of figure. So let us say you are pulling down, okay, one example, another example is a well, okay, so let us say you have a well and then it is connected to a pulley and then you are trying to pull it out, okay. So in this case, okay, there's a pail inside that well, okay. You are trying to pull out some water out of it, okay. So let us say that your particle A will be the pail and then your particle B is you, okay. So it doesn't mean that those two particles we are talking about are non-living things, okay. So it could be that you as a person, you could also be the particle, okay. So let us visit, okay. So how do we explain this motion analysis, okay. So here we could write up, okay, an equation using in motion analysis. So we have SA plus X plus SB. Okay, so let us say that this is equivalent to your total length. Okay, so let us say your LT is your total length. It's given. Okay, so if you differentiate this equation, you will get, okay, so maybe we'll transfer it, okay, you can also rewrite it, you transfer it to the right, so it will be LT, okay. So in this situation, okay, so there are two variables here. It is the SA and the SB. Okay, why? Because this length SA, okay, let us say if your particle A will already be here, so normally your SA will shorten, and then your SB, there is a possibility that it will, okay, so it will, if it will go down, your SB will increase, okay. So therefore the variables we can see here is only the SA and SB, and your total length and this X, which is the length between SA and SB in this diagram, okay, it is being pulled by let us say this is the pulley, okay. So the length of this pulley is X and it is constant, so this is constant, okay. So this is constant. I hope you understand what I mean by constant, okay. So the total length here is constant. The X here, or the distance, okay, of this pulley between SA and SB is constant, but your SA and your SB is changing. So therefore, your changing variables is the SA and the SB, okay. So once we differentiate this one in order to get your velocity, we will get this VA plus VB is equal to 0. Okay? So how do we get VA plus VB is equal to 0? We differentiate these distances, okay? So these figures relative to time, okay? So remember that, okay, your ds over dt is equal to velocity. Okay? So therefore, your ds sub a over dt is equivalent to your velocity a. And also, dsb over dt is equivalent to velocity b. And since x and sb are constants, so therefore, if you differentiate them with respect to time, okay, so dx over dt is equal to 0 since x is constant. And then, if you differentiate, not SB, but LT, okay? So, your LT, when you differentiate your LT or the total length, with respect to time, you will get 0, okay? So, I will just repeat. As you can imagine, even no matter how far this SB will go, and then your SA will go upward, while your SB goes downward, the total length of the rope, okay, pulling from SA to SB, okay, this total length SA plus X plus SB will always be constant. Only your SA and SB are changing. So that's why if you differentiate this formula, okay, so this if you differentiate this mathematical expression, you will get VA plus VB. Okay? And then again, if you differentiate again this mathematical expression, you will get, okay? So if you differentiate, okay? So just remember the relationship that if you differentiate velocity with respect to time, you will get acceleration. So therefore, if you differentiate velocity A with respect to time, you will get A sub A. And then, also, if you differentiate velocity B with respect to time, we will get acceleration B. So therefore, you will have 3 equations. Okay. So differentiating this one, in order to get another mathematical expressions. So you will get 3 equations. And depending upon the given, you can solve the problem of what will be your velocity and acceleration of each particles, okay, in this figure. Okay. So maybe we visit this one. Okay. So let's have another example, okay? So maybe we'll tackle about this problem, okay? So let us say you are the pail inside the well is your particle A, and you are the particle B. Since you are the one pulling the well, this pail out from inside the well. Okay, so let us say this is the well. Okay, so let us have okay, I will erase this one. So here you have the particle A. So this is your S sub A. Okay, so how do you name SA and S sub B? So if your SA is your rope or your pulley, or this portion of the pulley is pulling out A, so you automatically you will name it S sub A. So if that portion of the pulley or that rope is connected to B, so you name that S sub B. So this is your S sub A and this is your S sub B. So that is how you do it, okay? So therefore, you also, the length of the pulley will not be complete. Let us say this is X also, okay? So therefore, it's the same. So you can rewrite the formula SA plus X plus SB is equal to LT. Okay? So as you pull downward this, the pail, so there will be a time in which your SB will increase. Okay? So there will be a time that your SB will increase and your SA will decrease. When your pail, let us say that it will goes upward in this, okay? It will goes upward by a height of h. So if this pail will travel uh, upward uh, h, okay, measured h meters, so this SB will also increase by h meters. Okay, it depends. Okay, so therefore your two variables here, when we say variable, changing, okay, changing values is your SA and your SB respectively. Okay, so therefore SA and SB are the only things, and are the only one that are the only two expressions is in this mathematical phrase that will have a value when differentiated. Okay, so therefore SA plus X plus SB is equal to length, the total length of this rope in this pulley. So therefore, when you differentiate it, since this X is constant, L sub T is constant, so you will get V sub A plus V sub B is equal to 0. And then we have acceleration A plus acceleration B is equal to 0 also. Okay? So you okay? So I get this VA plus BB when I differentiate this mathematical expression relative to time. And then okay, if you differentiate your velocity again with respect to time, this is expression, I differentiate it again, so I get this another mathematical expression. Okay, so you have three equations and three equations to solve the problem. Okay, so it should be that some things are given. Okay, so let us say VA is given so that you can compute your VB. And then, so if that is the case, you can also compute the other parameters in this problem. Okay, so it depends upon the given. Okay, so maybe let's have another example. Okay, so maybe I will erase this. Erase this one. So let us say your pulley is not that, it's quite complicated. Let us say like this. Okay, so let us say your equation will be like this. Your figure will be like this. Okay. So therefore, okay, so let us say this is your pulley. And let us say that your portion, your A is moving upward. Okay, so if it moves upward, this B will go downward. Okay, so how do we construct your formulas? Okay, so if this is your S sub A, so we can say, okay, so we can say that this will be your S sub B, okay? Okay, so you can also rewrite, okay? So what is changing? Okay, so I know this is constant. Okay, so this is constant. So if it will go down, so the thing that is changing will be this length. Okay? So if it goes upward, so therefore there is such a time that your portion A will be in this portion, and then your in this location, and your B will be at this location. Okay, so if it goes upward by at distance h, so your B will also go down at distance h. Okay, so therefore you can construct formulas. Okay, so here, please do remember that there are actually two lengths. You have SB, SA, SB, okay? And we have this formula. Let us say this is Y, okay? So therefore, the length of this rope, I know, let us say this is Y. So since it is moving, this is also changing, so this will be SB minus Y. Okay, so if that is the case, okay, so for clarity, I will erase the direction of motion. So this is the direction of motion of B. So this will be SB, SB minus Y. Okay, so why I put Y here? Okay, so no matter how far this B will go downward and your SA will go upward, this distance will be constant. What is changing is this and this. This distance and this distance. So since this is constant, let us say it is Y. So this will be SB minus Y. So therefore, we can construct our formulas. Okay, so we'll have our formulas describing the motion analysis of two particles. So we have S sub A plus Y. Okay, so maybe I'll put it in another another board. So here. So we'll have S sub A. Okay. So may I check if it could be seen? Okay. So we have S sub A. Okay, so from this figure, we have S sub A, and then plus S sub B minus Y, plus Y plus S sub B minus Y plus S sub B is equal to the total length. Okay? And then we have, okay, so we simplify this expression, we can get S sub A, the Y will cancel out, so we have S sub A plus 2S sub B is equal to L sub T. So this will be your first formula. Okay, so in order to get the second formula, which includes velocity, so we differentiate this expression with respect to time. We can get V sub A plus 2V sub B is equal to 0. And then we differentiate velocity again in order that we can get the acceleration. So we get A sub A plus 2A sub B is equal to 0. Okay? So that is how you construct formulas for motion analysis. Okay? So for absolute dependent motion analysis of two particles. Okay? So we will have examples, okay, on the next videos.